Hi, this is Lori, and this is my homework for Paul McWhorter's Pico W course. We're on lesson 56, and we're starting to use a joystick with our Pico. Okay, for my first program, I'm going to show how the joystick, how to read the joystick as Paul taught us. I just thought I'd share a couple of pointers that I found. This is the kind of joystick that we get in our kit, and I don't know. I don't like how we have to connect them up with the wires and then they kind of just sit here and move around. You kind of have to hold on to them. You can't mount them somehow onto the breadboard. And I hate that. I really hate that. So I started looking around for something that I could put into my breadboard for prototyping. And I found these ones from Adafruit that have a little mounting board here that you can then put pins on that you can put right into a breadboard. So I really like these, and I think they're a tad higher quality than the ones we get in our kit. I recommend them for breadboarding. Now, obviously, if you're using this for a game, I don't think these are good enough for like a real game, like you're making your own game pad or something. I don't think these are good enough for that. But anyways, that's what I have mounted here, and that's why it's different than what's in the kit, because then I can have it all nicely into my breadboard. So now you can see kind of the layout I have, and I have it hooked up to it, and just neater and tidier, and you can kind of get it pretty firmly on the board for messing around. All right, the other thing you may notice here is that I still have my NeoPixel, because I'm not done doing stuff with my NeoPixels, and I'm going to figure out a way to incorporate the joystick in my NeoPixels. All right, but this first program is just reading the joystick, and then I also, and I'm sure Paul's going to tell us this, but you also have a button switch when you press down on your joystick, and you can activate something, using the button. So I'm just setting up the button to use it, and then I'm going to read here, and I'll check the button status, and if it's 0, then it's pressed, and if it's given a 1, then it's going to indicate it's not pressed. And so we'll just print out all that to the screen, sleep for a little bit, and keep going around and around. So it's just to demonstrate that the joystick's working. So let's go ahead and give it a run. There you can see the status of the joystick, and you can see as I move around, it changes. And if I press the button, so I have it set up sort of as a momentary switch. So if I press, it says pressed. It doesn't. So yeah, that works pretty well. All right, let's see what I did to connect up the joystick to the matrix. All right, so now we'll talk about the program I wrote to connect up the joystick to the matrix. So the idea is that the joystick will move the lighted NeoPixel around, and based on where we move it to, it'll move the light around. So that was my thought, and then I wanted to use the button too. So if you press the button in, it'll randomly pick a color out of the color dictionary and change the color of the light that you can move around with the joystick. So that's the concept of the program. And I'll be mapping, instead of what Paul requested us to do, which was map from 0 to 100, I'll be mapping the joystick values from the potentiometer to 0, 1, 2, 3, or 4 in terms of what row I'm on here, or what column is the pixel that's going to get lit will be. So same concept. So let's see. All right, we'll set up our NeoPixel. We'll set up the joystick here. And I copied over some of the functions I used during the NeoPixel classes. Brightness function I put together, and the clear function. And then I made this function before, either in some homework or a project I did. It's to do the math that Paul always shows us how to map one range of numbers into another range of numbers linearly. So that's what I wrote my own function to do that. So I kind of got tired of doing the math by hand. So this function just lets me do that pretty easily. And then the concept is we need to move, we're going to light the pixel here and then we're going to move it around based on where we are. And that's pretty easy to do on like a display where your display is in an XY coordinate system, and you can kind of move the pixel that's being lit, with the joystick. But because you kind of have an XY grid, so that works really nicely. In this case, in concept, you have an XY grid because you could number these something convenient, the rows and columns, but that's not how you address the pixels. You address the pixels based on their pixel number. And this matrix, starts here with pixel 0, goes up to 4, then it comes down this column, and it goes this way, kind of like a snake. So, I needed a strategy for referring to these pixel numbers, but still thinking about it as an XY coordinate system. Now, the way I thought of doing it, I feel like in my heart, I feel like there's a slicker way to do this, but I'm a fan of dictionaries, so I immediately thought of using a dictionary where I created this, and I wrote it right here, but in my mind I'm thinking about this thing as like a small display that only has 25 pixels on it. And it's an XY coordinate system drawn as I've shown here. And I decided I would just use a dictionary to link those coordinates to the actual pixel number. So you can see the 0, 0 coordinate links to pixel number 24, and the 4, 4 would link to 0, and you can see it's 0 here. So that's how I did it. I kind of used the dictionary to look up the pixel number based on the grid that I set up. All right, so I'm going to start off at the 2, 2 position, but this thing's a little bit off, and it centers when you're not touching it. It centers right here in the 1, 2 position, which is fine. Doesn't matter really. And I set an initial color to blue. And then we get into our while true loop, and we read the x and y position. And now we're going to use that map function to change the reading from the potentiometer, which is about 500 to 65, 535. And I want to change it to a range of 0 to 4. And same thing for the y, same idea. And then I need to read the button as well in case the user has pressed the button and they need to get a new color. And so if the button has been pressed, it'll read a 0, and we'll do a random choice of the list of the colors in the color dictionary. And that'll allow us to change the color. We'll clear the matrix. We'll figure out what the current pixel is, and we're going to look up the matrix dictionary, what the X grid and Y grid value is. What is that one? That'll tell us the pixel that needs to be lit. Then we'll light that particular pixel in the matrix, write that, and you can see it's using the new color, whatever new color is set to, and then it sleeps, and we're printing some of this to the screen just for debugging purposes, and then if we do a keyboard interrupt, we'll clear the screen. All right, so hopefully that made some sense. And hey, if you have a more interesting way to think about how to do this, I would be very interested in hearing your thoughts on that. Anyways, it works what I'm doing, and I don't think it's too inelegant, but I feel like there might be a more elegant way to do it. All right, so we're starting off with blue, and you can see where it settles. It settles on this pixel here when you're not touching it. But if we move it, you can see that we can move all around the matrix and light any pixel we want. And then if I press the button, I can change the color. And well, there we go, red, and so forth. So yeah. Well, that's my homework. Thank you for a great lesson, Paul, and thank you for watching.